When it comes to sustainable road transport, the big question is there a one-size-fits-all solution? That's why I've come here to the Department of Engineering at Cambridge University to speak with David Cebon, University Professor and Director of the Centre for Sustainable Road Freight, to find out more. Great to be speaking with you today, David, about the topic of sustainable road transport. So why is this such an important topic, and what does the current landscape look like within the industry?
One thing in context, I guess, is that the government has said it would phase out trucks less than 26 tonnes by 2035. So stop selling those trucks, fossil fuel powered trucks, so they have to become electric or zero emissions trucks by 2035. And the bigger trucks, the 44 tonne ones that drive up and down the motorway, they have to stop selling those in 2040. So the firing pistol has been set from the industry's point of view, so the industry has to change. I think the other aspect of it is that the freight and logistics proportion of carbon emissions concerned with freight and logistics is going up. And the reason for that is that where all other sectors are decarbonising, the power sector and transport and so on, the amount of freight and logistics traffic is going up, right? So that the demand for freight and logistics for truck journeys is going up. And that means that the proportion of emissions from freight and logistics is going up significantly. Currently about 7% of all UK emissions come from trucks and vans. That's rapidly going to rise to 10, 12, 15% as everything else decarbonises, and unless the freight and logistics industry can do something about it. So it's very important for the industry to grab this and run with it. There's a lot of work in industry on trying to improve efficiency of vehicles, trying to improve aerodynamics, to use lower rolling resistance tyres, those kinds of things. There's a bit of a shift going on to gas-powered vehicles. Some of the bigger operators are running vehicles on gas. That gives lower carbon emissions, 15% lower carbon emissions, and reduces those kind of noxious particulate emissions that you get from diesel. So there's a bit of a shift to that. But in many ways, I think that the industry is waiting to see what happens in the next 5 or so years. Are going to be pretty critical for making decisions about the big shift to the next thing away from diesel. Certainly in the smaller sector of the market, in the vans and urban delivery vehicles and so on, they are electrifying pretty quickly. Home delivery vehicles and those kinds of things. They're electrifying quickly, and they're largely following the trend to electrification in cars. Of course, the charging arrangements are different, and the charging arrangements in many ways in the electric future is the charging which really defines how things work in many ways more than the vehicle.
And when it comes to large good vehicles, is electric the answer for them as well, and what are some of the limitations?
Electric is the answer, certainly for the UK and Europe. It's more difficult when you start to think about having to drive across Australia or across the United States or India. It's more difficult to work out how that will work. But for highly populated countries in Europe where there are motorways with a lot of traffic and journeys are relatively short. We don't typically drive thousands of kilometres at a stretch across the desert in Europe. It's quite different. So I think that electric vehicles are ideal actually for Europe, UK and European conditions. The challenge is to charge them. You really can't carry enough electricity to go all day. not really practical. If you want to go all day, you need batteries which weigh many tons and cost many hundreds of thousands of pounds, and just too expensive, and it's too much reduction in payload for the vehicles. So that really doesn't work. That's a sort of really big battery solution. What you have to do is to charge the vehicles during the day, one way or another. And there are opportunities for doing that, particularly using the kind of fast charging technologies which are appearing. And the opportunities there are to charge when you do deliveries. When the vehicles drive into a warehouse, they've got half an hour, perhaps 20 minutes or half an hour to unload and load up. They could charge then, and that kind of sipping of charge for a short period of time can make an enormous difference. And then the other place where they'll need to charge, or other two places they need to charge, first of all would be truck stops, services, motorway services, that kind of thing. And the third one is the possibility of charging actually while in motion using overhead wires that go along the main roads like railway lines, with trucks having a pantograph which reaches up to the overhead lines. The advantage of that is you can power the vehicles in motion, and you can also charge up the batteries while you're driving along. So that takes away a need for a lot of those chargers in warehouses, and a lot of them need to stop, actually.
So in terms of those infrastructure requirements, where are we today? Where do we need to get to, and how viable is that?
Overhead line solution that I mentioned is well-developed technology. It's in use in Germany on the motorway, on the A5 motorway outside of Frankfurt Airport. And that's there's 5 kilometres of that, and it's being extended by another 5 or 10. So that's a very successful project, operating in day-to-day traffic and showing that technology works very well. There are trials being discussed there have been trials in Sweden, trials being discussed in the Netherlands and in France. So there's a lot of interest in that technology in Europe. And I think it's important, UK is partly separated from Europe, but not completely, and certainly our freight and logistics operations, there's lots of vehicles drive across the channel, go across the channel on ferries and so on, take freight from here to there and there to here. So we can't separate ourselves from what goes on in Europe, and if Europe goes, broadly to one kind of technology, then the UK will pretty much have to go to that technology. So I think that's a really important consideration. The UK can't be independent here. We can't have a situation where you can drive trucks in the UK, but you can't drive them to Europe, or vice versa. That's completely out of the question. So there's very few things which are absolutely fixed, but it seems to me that's one of the things which is absolutely fixed. So there's a lot of interest in this technology in Europe. That's not to say that it's a definite thing, but it's important for the UK to take that into account. So the technology is relatively well advanced. In terms of the costs, the important thing to realise here is that one of the equations that's important is, on the one hand, putting up overhead wires along some length of motorway, and on the other hand, the size of the batteries in 200,000 trucks. And that's a sort of strange thing to say, but if you have long wires, then all those trucks only need small batteries. And they need batteries because they go off, when they leave the motorway, which has got the wires, they'll take down their pantograph, drive to their warehouse or depot or whatever, drop off the load, drive back. So they have a battery to just take them the distance off the motorway. And for many of the trucks in the country, that's short. They mainly spend their time going up and down the motorway, driving to warehouses in places like Milton Keynes and Daventry. You see these huge clusters of warehouses in those places. So in many cases, if you have lots of wires, those trucks can have really small batteries, very small batteries, the sort of batteries the size in a Tesla car. On the other hand, if you have a small section of wires, then what you have to do is put much bigger batteries into about 200,000 of those big trucks which drive around the country. So the balance of that equation is not obvious. It's not obvious that putting big batteries into the most expensive component in an electric truck, right, is the battery. So putting big batteries in electric trucks is actually more expensive. We know it is more expensive than building the infrastructure on the highway. So the cost of infrastructure on the highway is manageable. Our calculations are that you need about £20 billion to build as much infrastructure as we need on the highway. Well, that sounds like a huge amount of money, but if you compare it to other uses of money for those kinds of infrastructure projects, it's not. So you could compare it to Department of Transport's budget for the period 2020 to 25, budget for motorways, 2020 to 25, which is 28 billion, right, which is 50% more than we're talking about. You could compare it to HS2, which last I heard was 106 billion, 5 times what we're talking about. So for a fifth of the cost of HS2, you're talking about decarbonising all the trucks in the country, or at least all those that are on the motorway, about 65% of them. And that actually, I think, is the cheapest you can decarbonise just about anything. Attraction of hydrogen-powered trucks is that they look like they can kind of operate in the same way as existing diesel-powered trucks. That is, you fill them up, once a day or something, and they can drive anywhere in a kind of flexible way. That's the attraction of them. The downside of hydrogen-powered trucks is that they are much more expensive. Capital cost is much more expensive than electric trucks, and very much more expensive to operate. And in particular, if you compare that a hydrogen-powered truck with a Catenary cable-powered truck, they both get their energy from electricity. If you use what's called green hydrogen, that is hydrogen made from electricity, both of these vehicles get their energy from electricity, but it takes 3.3 times more electricity to power the hydrogen truck than the electric road truck. That's because hydrogen processes are inherently inefficient. So you take the electricity, you convert it from AC to DC, you put it through an electrolyzer. Electrolyzer about 75% efficient. You generate hydrogen, compress it, store it, transport it, put it through a fuel cell. The fuel cell is about 50% efficient. All of these processes have inefficiencies. By the time you get to the end of all of that, you've thrown away about 77-80% of the energy. Right? It's just been dissipated as heat. And you only end up with about 25% of the electricity you started with as electricity going to the vehicle. So you started with electricity, you created hydrogen, you go back to electricity again, but in the process you've thrown away 75% of it. So that means, because somebody has to pay for that electricity, that energy that's been wasted through those processes, it doesn't come for free. So, and it's the end user who has to pay for it. So you have to generate 3.3 times more electricity to go that route than if you just take the electricity, put it into lines and put it straight into the motor of the vehicle. So that 3.3, factor of 3.3 is very important, because it means that you need 3.3 times more times generating capacity. Right? You can't just put more fuel in the tank. You have to have 3.3 times more wind turbines or solar panels or nuclear power stations or wherever you get your green electricity from. You have to have 3.3 times more of it. And that's a significant thing. It needs 3.3 times more staff, 3.3 times more maintenance, 3.3 times more capital cost, 3.3 times more running cost. It's 3.3. And that 3.3 comes from thermodynamics. It can change a little bit. Maybe it'll change to 3.2, maybe even change to 3.1, but it's not going to change significantly from there, because it comes from the fundamental engineering, the thermodynamics of all of those conversion processes, and they don't change. They're already as efficient as people can make them, near enough. This slide shows a map of the UK, and it shows what would happen if you powered your electric Catenary trucks or your hydrogen trucks with onshore wind turbines. And it shows the size of the areas of wind turbines that you need. So the circle at the top shows that you need about 11 gigawatts of power to power ERS, that is electric road system vehicles, the overhead catenary line vehicles. And you can see the little circle there. You need about 3,500 land turbines. That would take about 5,000 square kilometres, the size of that smaller circle. If you did it by hydrogen, of course, you need 3.3 times more electricity, and that's the bigger circle. So the bigger circle needs about 35 gigawatts of electricity generating capacity and about 12,000 wind turbines, and an area which is about the size of Wales and Yorkshire put together. Right? And you can see what a dramatic difference that makes to have to, this is just to power trucks now, never mind heating buildings and powering industry and all the other things that we need to do with our electrification system. Just to power trucks, you need to build that many wind turbines. Now, of course, they're probably not going to be on land. They might be in the North Sea. I could draw you an equivalent picture for the amount of sea area that would be involved. But it really highlights the point that in the electric future, you can't just put a bit more diesel in the tank. You actually have to build this electrical generating capacity and storage capacity which goes with it, and so on. And this factor of 3.3 then becomes a really dramatic difference between between these two different solutions. So land area and amount of renewables is important. And I think the other aspect of it is that actually building that amount of renewables is incredibly difficult. So if you opt for a hydrogen solution, what you're opting for is having to build a hell of a lot more renewables. That's going to take a long time, and it's going to make it much more difficult to decarbonize everything else. So, the scale of electricity generation that we're talking about is really big compared to what the country has to do already. And so going for a hydrogen solution is likely to delay the decarbonisation process, make it much more difficult for us to get to 2050. So what that means is that the amount of that the running cost for hydrogen powered vehicles is going to be much higher, but also the vehicle cost is higher. Both the hydrogen powered and electric catenary powered vehicle they're essentially the same vehicle, right? They have the basic platform, they have electric drivetrain, they both have batteries, they both have inverters, and so it's a question of what else you add. You can add a bigger battery. On the one hand, you can add an overhead catenary pantograph, or you can add a hydrogen fuel cell and hydrogen tanks and all that stuff. But it's all added to that same electric platform. Now, the cheapest thing you can add is the pantograph, 10,000 pounds worth of mechanical kit you stick on top of the truck. The most expensive thing you can add is either a huge battery or a fuel cell and all that, hydrogen infrastructure. Fuel cells full of platinum and all kinds of, it's expensive technology. So just depending on the size of the battery compared to the size of the fuel cell kit, one or other is going to be more expensive, but they are much more expensive than just sticking a 10,000 pound pantograph on the vehicle. So the pantograph truck is much cheaper, has a much smaller battery, is actually much more energy efficient than even the battery powered vehicle, because electricity just comes down the wire and goes straight into the motor. It doesn't have to go in and out of the battery, which it does in a battery electric vehicle. So it's more efficient, it's lower cost, it's lighter, carries more stuff. So even though it seems like a unattractive thing to do, to have to put up all that infrastructure, you end up with a much more environmentally friendly system, where instead of huge batteries on every truck, you've got very small batteries, relatively small batteries. There's these big batteries come with a cost. So if we can reduce our dependence on those big batteries, on lithium and so on, we can reduce environmental impacts, and that's all good. So all aspects of the Catenary trucking are better. It's cheaper, lower carbon, lower environmental emissions impacts, and it's available, ready to go now. The disadvantage, of course, is you've got to build infrastructure. And the only disadvantage there is that it requires government to get involved. You can't build a big infrastructure project without government getting involved, not of this scale of project. And it doesn't mean that government has to pay for it, but it does take some commitment from government, and it's not a solution that the free market will come up with. All right, the free market won't come up with that solution. It will come up with something that small companies can do easily themselves. So that's the disadvantage. But from an environmental point of view, even from the point of view of the rate of decarbonisation, the rate at which we can get the country to change, it's hugely beneficial to go over the Catenary overhead lines. So that's why we're very interested in the Centre of Sustainable Road Freight, because it's by far the most sustainable option that we've got in the UK.
And as for alternative fuels, what place do they have in this conversation?
I think that during this transition period, everybody needs to do whatever they can. And biofuels really have a place. HVO on the one hand and biogas on the other, both important solutions and both important ways for the industry to decarbonise in the short term, or at least to the extent that there's available HVO and available biogas. And ultimately the problem is the amount that there is available. In the longer term, we've seen, discussed how it's perfectly possible to do electric vehicles, and under those circumstances that's really what you should do. The biofuels are going to become increasingly precious, and they are very important. They shouldn't be used, in my view, they shouldn't be used except in the most extreme bits of trucking, possibly. Where they should be used is probably in shipping. Shipping has got a much more difficult job to do. It can't electrify in the same way, can't have static charges and overhead lines for ships. Shipping is much more difficult. There is quite a lot of biofuel in the world, combination of HVO and other sorts of biofuel and biogas. If you put it all together, I think my calculation is that there's about enough to run those long-haul ships on, and that's probably the best use for it. So I see HVO as it's an important fuel for the future. It's a transition fuel for the trucking industry, and it helps people decarbonise right now using the engines they've got, and that's a great thing. So we should definitely be doing that to the extent that there's enough of it to go around.
So you obviously speak to a lot of operators within the industry. What do they think? What are they telling you?
At the moment, I don't think operators are pushing back on electrification. I think they're jumping into it for their urban operations. I think as far as the long haul is concerned, they really want to see what's going to happen. They're not naturally not willing to make a decision about going in one direction if they're just going to find the whole industry goes in some other direction. So they're waiting. Quite a few operators are running small-scale trials, try out one or two electric vehicles or hydrogen-powered vehicles or whatever. They're trying to get their own information, but they're not pushing back, they're just waiting. I think it will be challenging. The operators that get the most attention are the big ones, the supermarkets and the parcel carriers and so on. But we always have to remember that most trucks in the UK are driven are run by small companies, companies that have five or less trucks, and they are in a much more difficult position, I think, than the big operators. First of all, there's they don't have the resources and they don't have the expertise to be really looking forward and trialling vehicles and putting their effort into this decarbonisation. They're really, very much concerned about the day-to-day operations, and what's going to happen in 10 years' time really is not at the forefront of their minds. So those companies, I think it's much more difficult. There's another interesting aspect of this, which is that those companies often do the difficult logistics tasks out around the wilds of Norfolk or Scotland, or they often do the more difficult operations, whereas the supermarkets do their line haul up and down the motorway. The smaller companies pick up these other routes. Now those other routes are more difficult actually from an electrification point of view. They will require more flexible vehicles with bigger batteries. They'll be more expensive vehicles because of the bigger batteries. So they're at a natural disadvantage, and it's hard to see how that's going to play out, that problem. It's a sort of unfairness of being small. And I don't hear very much about it, but I think this is going to be an important part of the transition. It's much easier for the big fleet operators to shift than it is for the small companies. So this will run, and I think there's going to be significant changes to the way that logistics are done. I think logistics industry is in for a fairly bumpy time through this. It's not going to be easy, but that's one of the pressures that I can see, is this, that it's going to be more difficult, relatively more difficult for the small operators than it is for the big operators.
And do you have a view on how it will all pan out?
It's really hard to speculate. I think one of the things about this energy transition is everything is changing at once. All right, it's not just a sort of a simple straight line. The energy system is changing, the logistics system is changing, customer expectations are changing, the environmental situation is changing, and I think that the dynamics of how logistics industry works, we're getting autonomous vehicles coming in this, probably quite likely in the same period. Autonomous trucks, I think we'll see before we see autonomous cars, because there's so much financial benefit in running a truck which doesn't need a driver. So I think we'll see all of these changes, and the thing about it is it's all happening at once, right? So any company that's trying to work out where it's going has got to do it in the knowledge that when it gets there, everything else is going to be different. That makes it really, really difficult. And so it's very difficult to predict anything that's going to happen. Who would have predicted war and pandemic, apart from anything else? But all of these other changes of the energy transition, it's really an unprecedented time. I don't think there's ever been a time in human history when everything had to change, to flip in the way that we're talking about flipping in the next 10 or 15 years. And so predicting anything is a complete mug's game, I'd say. I couldn't say how it's going to turn out. But I think that I think what's likely is that there will be significant changes in the industry, but I don't know what they'll be.
So what sort of things are the industry doing at the moment?
Rubbish trucks are going electric, buses are going electric, and other kinds of urban delivery, smaller urban delivery vehicles, rigid vehicles, not articulated, but rigid urban delivery vehicles are gradually starting to go electric. And I think when we look, this is going to happen pretty quickly. We'll look back in 10 or 15 years' time and we'll wonder why we ever drove diesel trucks and buses in cities, because the electric versions are cleaner and quieter and much more pleasant for the population. But also they'll be cheaper to run for the freight industry as well. So they're good. They're really good all around. Importantly, I think that the technologies that are being developed for the vans and then these smaller urban delivery applications, that's providing, building a supply chain for electric drives and batteries and electric trucking in general. And so I think that's really helping the truck manufacturers to tool up for the much bigger end of the market, those 44-ton trucks that go up and down the motorway. So we've got a kind of gradual progression through the applications, through battery electric applications, which can be done. It's not that difficult for a rubbish truck to charge up in the depot, to do lots and lots of collections during, over a few hours, to drive back, dump its load, charge up a bit more, and then go back out again. So these are applications where electric works really well. Same with buses. Buses go backwards and forwards along the same route. If they can sip a little bit of charge at either end of the route, you can actually do it with relatively small battery, and it's a great application. So this is all about the charging infrastructure.
You've mentioned, David, that many operators are waiting and seeing, biding their time, how things will pan out. So what needs to happen for things to move forward? Who needs to make that first step?
I think Department of Transport is doing the right thing, and they're in the process of developing some reasonably large-scale trials of the main technologies. Hydrogen trial, big battery electric trial, we hope an overhead Catenary line trial. We've just been through a process of feasibility studies. There have been quite a number of different feasibility studies for those trials, which were run through a Innovate UK process. So they're planning over the next 2, 3, 4 years to run some big trials, and then to kind of decide. It's an interesting thing. There's all kinds of practical issues that need to be looked at for all those three technologies, but ultimately it's the economics, I think, of those solutions which will decide what happens. The interesting thing, I think, is that economics can be worked out now pretty much. So, and it's not clear that these trials are going to help with that decision. We can do those economic calculations now, just as we can do them in 3 years' time. But we can learn a lot about the practicalities of these systems. So I think that's the right thing to do. I think if there are a couple of other things. One is that all of those three systems will require significant amounts of electricity by the side of the road, one way or another. It's either going to be for the overhead lines, to plug into overhead lines, as I said, or charging points at truck stops, or quite possibly electrolyzers for making green hydrogen at motorway services kind of locations. So all of those require upgrading the electricity grid and installing big grid connections. Now, those grid connections often take many years to organise and install. These are big projects in their own right. So whatever solution we have, it's going to need that, and that's something that government could get going on right away. A program of strategic investment in that major large-scale electricity infrastructure for powering vehicles. Of course, there's already a program of that going on for charging cars, and my view is that should be, and not just mine, various people think that should be boosted so that the needs of truck charging can be included. So I think that's the second thing. I think the third thing in the longer term is that there is going to have to be significant infrastructure spend here. Either, all of those three solutions are going to require significant expenditure. There will be need for static chargers throughout the country, static charging points at truck stops and so on. There are some real anomalies in the way that you buy electricity when you need to install a larger electricity connection. There are some real anomalies as to how that works, which make it difficult. I've got one member of my consortium said to me, I can put 25 vans, electric vans in this depot, but if I want to put the 26th one in, it's going to cost me £5 million, right? Because I've got to put in a new electricity connection. And so there's these funny anomalies in how electricity is purchased, which are a significant barrier. So that's another place where government can operate, could start to do things the way that electricity is charged, and particularly those new connections. And then the other thing, I think, is where you've got these big infrastructure projects, for example, the overhead lines, the electric road system. The challenge in getting that to happen is that you've got to build the infrastructure before you can drive trucks on it. And you can't generate any revenue from the overhead lines until you're driving trucks on it. So you've got this sort of process, which is build infrastructure, build up the number of trucks, then you're generating revenue. Now, that makes it difficult to invest, right? For investors to invest in a project which is going to take, 5 years or 7 years before it starts to generate real revenue, that is difficult. That's like, any big infrastructure project. And in those places, government support to guarantee prices or whatever, it's done in the electrical, in the nuclear industry, for example, guarantees of prices and so on. So government support to guarantee the business model so that private industry can come in without serious risk and invest is really the sort of thing that we've got to be thinking about. So there's a bunch of different things that government can do, some shorter term and some longer term. In the short term, dealing with the cost of adding electrical connections to the grid would be very valuable, and thinking about rolling out electrification around the network, also very valuable.
So the manufacturers then, what are they doing, and what do they need to do?
The first thing is that what they are doing and what they need to do is they need to build these electric trucks that can carry the kind of load. So one other thing that the government might need to do is to make some small changes to vehicle weights and dimensions. And that will be a European thing most likely, but the small increases in length to allow space for batteries, and modest increases in weights, which are always very controversial when they happen. But they are things that could make quite a big difference, and I suspect we might see some changes in weights and dimensions for tractor units coming through from Department of Transport and coming through from Europe. So I think that's another thing that will happen. What the industry can do, of course, it can learn how to make battery electric trucks. As I said, all trucks will be on this sort of battery electric platform, whether they have big batteries or overhead wires or fuel cells added. They're all going to be on that sort of platform. So there are a few things I think that the industry can do. One interesting thing I think is that flexibility is a really important thing for freight operators. And flexibility comes in all kinds of forms. It may just mean putting a truck with a bigger battery on, but it might mean being able to shift batteries from one truck to another truck. So let me give you an example of that. If you have this world of the overhead catenary lines, you have quite a large proportion of trucks just driving up and down the motorway and only needing small batteries. But there will be a small proportion of trucks that have to go out tramping around the wilds, multi-dropping around the east of England or Norfolk or whatever. Those trucks need much bigger batteries. Now, the way that fleet operators run their vehicles now is they tend to mix them all up so that, they buy a cohort of 100 trucks in 2022, and they'll mix them up all around the fleet and then sell them all on in 2028. And they would really like them to all have about the same mileage. and the same wear, and to just sort of sell them as a whole cohort. That doesn't work if you've got some trucks which are driving long distances up and down the motorway, and other trucks which are driving around the wilds of the country, some with small batteries and some with big batteries. So what would make a big difference in that particular regard is the ability to just swap batteries from one vehicle to another. So you can run these vehicles for 6 months up and down here, and then you can put some bigger batteries on them and run them on the more flexible journeys around the country. So just that ability to make vehicles that bit more modular and to swap components around, I think will make a big difference. The other thing is, I think that having hybrid range extenders, so small engines that can charge up the battery, I think that's an important part of the transition. At the moment, government is a bit allergic to that. They don't like the idea of hybrids, but I think hybrids are very important during the transition phase when you don't have enough electrification infrastructure built out, so you can't rely on it everywhere in the country. For example, if you had overhead lines in some part of the country but they hadn't been built in another part of the country, you've got to have a vehicle which can run in both parts, and the way to do that is with a hybrid range extender. At the moment, as I say, the government is allergic to the idea of hybrids. I think it would be very helpful if they softened that up and allowed hybrids during the transition period, so that the fleet operators could get that flexibility that they need, run electric when they can at low cost, but if necessary run diesel or gas or biogas or any number of things you could run a range extender on. That would be another very helpful thing to do. So I think that's another measure that government could apply.
So finally then, David, the next 10, 15 years, what does it look like? Where do we go from here?
Certainly increasing electrification in urban areas, we'll see that playing out. That's going to happen. A lot of that, has been driven by air quality regulations and zero emission zones and all that, and that's pushed that agenda forward much more quickly over the last 10 years than the carbon agenda. But so we'll see that electrification in the urban environment happening. As far as the long haul is concerned, I think it's got to shake out. We've got to shake out to a solution. I think one aspect of the solution which is particularly difficult is that at the moment there's only one kind of truck in the world, right? All trucks in the world are diesel, everywhere, whether they're running in Brazil or in Nigeria or in the UK, they're diesel trucks. And that's advantageous for the industry because it has a much smaller set of truck models and tools and smaller set of factories and economies of scale. It's very difficult to imagine a situation where you don't have some sort of uniform system, where the new system is not some sort of a uniform system a bit like that. For example, it's almost impossible to imagine that you're going to have hydrogen-powered trucks in Scotland and electric-powered trucks in England. It's just not going to happen, right? Or in Europe and the UK. And I think in the same way, probably all around the world, we're going to have to settle in on, not on one solution, but on a modular set of solutions that can be built easily. Now, I think we're seeing that modular set already. I think that the base of that modular set is the electric truck platform. You can add these things onto it, add more batteries to it, add a pantograph to it, add fuel cells to it, or add a range extender to it. If you do that, you can have essentially one vehicle platform, which is used all around the world in different modular combinations. And I think that is the likely direction of travel. That's, instead of having one type of diesel truck, we end up with modular electric vehicles. But exactly which modules we end up with is a bit of a question, whether it's going to be hydrogen fuel cells on the back or bigger batteries or overhead lines. And maybe different geographies will have different arrangements of those things. And maybe we'll see in places like Australia, you've got populated areas on the East Coast, hell of a lot of truck traffic on the East Coast. You could probably put overhead lines there, but there's no question of putting overhead lines across the desert from east to west. There's hardly any traffic goes across there, so you just wouldn't do that. So then you've got to say, well, how we do that? We'll probably have a hybrid vehicle running on HVO or something like that for those. But it's a basic electric vehicle, and when it gets into the built-up areas, it can run electric again. So I think thinking through those, how the whole world transitions, is really interesting. But that important thing is that this is not a decision for just one country. It's not just a decision for the UK Department of Transport. This is a decision that the whole world has got to solidify onto, a system that the whole world has got to solidify onto, and it's going to involve, the whole industry around the world. So it'll be very interesting to see how that shakes out and as we go forward.
Fantastic stuff, Professor David Cebon. Thank you.